Okay, for one of the techniques for this week's lab, I thought it would be the most fun to just bring you into my kitchen to show it to you. So here we are. Just so you know, this back here is Marge. This is a vanilla bean orchid. Let's get underway. I'll show you this technique. Okay, so from the lab handout, hopefully you've gathered that the purpose of this lab is to examine both acclimation and acute responses of crayfish to environments that vary in their salinity. So the original goal of this experiment was to first take a bunch of crayfish and then acclimate them to salinities that range from 0% up to 2.5%. And then we're going to take water samples and measure the salt levels both in the water sample and in the crayfish itself at each of these different, under each of these different acclimation conditions. Then we're also going to set up a test of crayfish acute responses to salinity. So we're going to take crayfish that were originally acclimated at either 0% or at 2% salinity, and we're going to expose them to a change in conditions. So the 0% crayfish, we're going to get exposed to 2% salinity, and then the 2% crayfish are going to get exposed either to 0% or to 3% salinity. And then we're going to track a couple of characteristics through time, so their body mass and then changes in sodium and chloride content. And for salt conditions, we're not working with just table salt here. So these crayfish last year were acclimated using a salt mix called Instant Ocean. So it's obviously configured to be very similar to salt levels that are in the ocean. So when Instant Ocean's prepared at a total concentration of 3.5%, so that's 3.5 grams per liter, here's what you wind up getting in terms of the percentages of all these different ions. So if we want to track what's happening with sodium and chloride individually, we have to measure each ion individually as well. Okay, for the purpose of this video, I don't have Instant Ocean at home, so instead I'm just going to wind up preparing a mixture of table salt, or as labeled here, slat. And then we're going to use a salt meter. So this is a type of salt meter by Hariba, to measure the total sodium present in the salt mixture that I'm going to prepare. All right, now the highest concentration that I mentioned that we used with the crayfish previously was at 3%, which is equivalent to 3 grams of salts per liter. Here at home, my volumetric measuring instrument is this nice Pyrex measuring cup, and so what I'm going to do to start out with to make some of this 3% solution is I'm going to measure out the equivalent amount for a 400 milliliter solution total. So for 400 milliliters at 3 grams per liter, so it's going to be, 1 liter has 1,000 mils in it. Getting back to our dimensional analysis, so 400 over 1,000 is going to give me 0.4 liters. And then if it's 3 grams of salts per liter, 0.4 times 3, I'm going to need a total of 1.2 grams of salt. Okay, so when you're doing this for home cooking, I've got a kitchen scale right here. So I'm just going to line that up here, pop this on, turn it on, and it will tare, hopefully. Okay, there we go. And it's an American scale, so its default units are ounces. That's silly, so I'm going to convert it to grams. And again, for my calculations, I'm going to measure out 1.2 grams to the best of my ability. So let's see how this goes. Okay, I don't have any decimal places, so I'm somewhere between 1 and 2 grams. So this is actually a good point to say, when you run into this type of situation, you need to make some adjustments to what you're doing since your instrument doesn't have the appropriate level of precision. So since I don't have enough precision to weigh out the amount that I'm after, I'm instead going to prepare a more concentrated solution, and then I can dilute down to the final concentration that I actually want. So in this case, I think it's probably safe to say I can probably measure about 10 grams of salt out. So let's get this going again. Okay. Okay, so there's, oh, yep, right at 10 grams. It's wavering right between 9 and 10. A few more grains. Okay, there we go. So now if I add up to, actually in this case with the Pyrex I can go up to 500 mils total. So, okay, so now if I've got a total of 10 grams, if I add 500 mils of water to that, you know, that's half of a liter. So if I can multiply by 2, so this is going to be the equivalent to 20 grams per liter of salt solution overall. So that's a 20% salt solution. So if I want to get to a 3% solution, then I need to use C1V1 equals C2V2. So here I've got 20%, so 0.2, and I don't know what volume I need. And for my next volume, I want to get down to 0.3%, so 0.03. And let's again prepare that to a total volume of 500 mils, okay? So then I'm just going to solve for V1, so that's going to be 0.03 times 500, and divided by 0.2. And in this case, I'm just going to do the math with a calculator. Okay, so I did that math with a calculator, and when I do that, I wind up getting an answer of, I need to add 75 mils of my concentrated solution to then 425 mils of water to get down to my 3% salt solution. Okay, so let's go ahead and do this. Okay, let's get a spoon. Now, this isn't going to be horribly accurate because the measurements on this cup are only in 100 milliliter units. So actually, as I keep thinking about this, what I'm going to do is I'm going to do a two-step dilution. So I'm going to go to 6% and then I'm going to go to 3%. So to get to 6%, I'm going to instead work with 150 mils of my concentrated solution and then 350 mils of water. So 150 mils of 20% is going to give me 6%. Then I'm going to cut that in half, do a 50-50 dilution to get to 3%. Okay. So first things first, I need to find another container to put the salt water into. This would be great for a practical joke, but I think I'm just going to pour it into a large jar I happen to have around. Okay. And yep, that's brought me down to 150. So I'm going to top up this Pyrex with more water. Okay, so right now, just to check, I'm at the 6% solution, and next I need to go down to 3%, so I'm going to do another 50-50 dilution. So I'm just going to pour off the top half of what I have here to get down to 250 mils. Okay, and then I'll top off again with more tap water. Okay, and voila, now I have my 3% salt solution. Now I'm going to want to make a standard curve, so I'm going to want to continue this process. So I'm going to save my 3% salt solution in a labeled container here. Mmm, delicious. Okay, so I'm just going to label that 3%. Okay. Okay, so that's nice and all that I've got a 3% solution, but if I want to generate a proper standard curve, I want to remind you that I was looking at crayfish that were acclimated to this range of different salt concentrations. So what I really am going to need is I'm going to need a 2.5% sodium solution, or salt solution, a 2%, 1.5%, 1%, 0.5%, and then 0%. Well, at least that one is easy, right? Okay, so we need to go through the same process again. In this case, I'm going to prepare a total of 400 milliliters of each concentration. So what I'm looking at is 0.025 times 400 equal to 0.03 times the volume of my 3% solution. Now, if I crunch those numbers, I'm just going to give you the math here. That's going to be 333 mils of the 3% solution. Then top off. So this is going to be pretty crude because, again, this Pyrex is not all that exact. I could do this by mass. That's probably a better idea. So actually, that's what we'll do rolling forward. So same kind of math is going to apply for the rest of these. So for 2%, I'm going to wind up needing 266.6 mils of the 3%. For 1.5%, I'm going to need 200 mils. For the 1%, I'm going to need 133 mils. And then for the 0.5%, I'm going to need 66.6 mils. Okay, so if we add all of that up, that's going to add up to more than the 500 mils of 3% that I've made so far. So thankfully, I can go back to my 20% and make some additional 3% salt solution so I have enough to finish everything out. Okay, so here is what I'm going to do is I've got this tang pitcher, so I'm just going to fill this tang pitcher up with the 3% that I've got so far. And you know, if you think about it, that might actually be kind of appropriate because tang is prepared as an electrolyte solution. So here we are with a 3% electrolyte solution in the tang pitcher. I'm going to go back through and I'm going to mix up some more of my 3% from my 20%, just going back over my previous math. So again, that was adding in 150 mils of the 20% to 350 mils of water. That gives me 6%. Okay, and I can just use this tang pitcher here to do my dilution. I'm just going to add that. Oh, now I'm out of space in the tang pitcher. I'm going to have to find another big jar, so keep sloshing liquids around here. Let's see. All right, tang pitcher ran out of space, so I'll put that into this even bigger jar here. Okay, and then if I just add another 500 mils of tap water. Like so. Now I've got a large jug full of 3% salt water. Much better. That should be enough to get me where I need to go. Okay, so mixing up this 2.5% solution, let's get some labels going here first. So 2.5%. And this jar is not going to hold that entire amount, but that's fine. I can just discard any excess that I produced. So I'm going to need 333 mils of my 3%. Okay. So I can start off just eyeballing that on the measuring cup. 339, let's back some of that off again. 321, here we go with a little back and forth. $332, that's pretty darn close. And we're going to get ourselves all the way up to 400 total, so I'm just going to add up to 400 here from the tap. Voila, 400, give or take. Okay, so there's my 2.5% salt solution. Yum, there we go. Okay, so up next we're going to do to 266.6 mils. Oh, slightly overshot again. Yep, definitely overshot again. Back and forth, back and forth. There we go. Okay, that's going to be as good as it is ever going to get. Okay, so again, this is my 2% solution. Always label your beakers. Okay, 2%, and we're going to top off to 400. So here we go, up to 400. $398, $399, $400. Close enough. Okay, so there's our 2% salt solution. Fabulous, trucking right along. I'm going to go through the same thing for all the remaining solutions now, and I'm probably going to just speed up the video for this part. Okay, great. So now I've got a range of concentrations of salt, so from 2.5 to 2 to 1.5 to 1 to 0.5. And I can also mix up a bit of 0%. I'll just put that in the Pyrex, just some straight tap water. Okay, put that back there. Okay, so now we need to talk about how do we actually measure salt. So here's the salt meter. I'm going to flip it on. Okay, and this one has some residual material left in it from a previous user in a previous year. That's kind of salty, very salty, sticky solution. So I think our first step is going to be to find a clean rag to wipe that off, get that clean. Okay, and what we have in here is just a little electrode. Okay, so let's clean that off. Okay. And then this comes with a couple different stock solutions. So here is pure deionized water, and then we've got a standard that's at a 0.5% concentration. There's a second standard at 5%, but that's above the range that we need to work with. So we're just going to work with the pure and the 0.5% standard for our standard curve. So I've got this filter paper, and what I'm going to do is I'm going to go find a pair of scissors. And this filter paper is very good at picking up small amounts of salt, so I'm going to avoid touching it with my fingers. Okay, so instead of touching it with my fingers, I've got this very fancy set of plastic forceps here. So I'm just going to reach in here with the forceps, pull out some of this filter paper. Then I will cut a piece of this filter paper, and to start out with, just to zero this out, I'm going to apply a little bit of this pure DI water to the filter paper. Okay, and look at that, magically my reading is at 0. Okay, that's great. So now let's test this 5% solution. There's a little bit of residual water there, so I'm just going to take another little piece of this filter paper. I'm going to use that to absorb the residual water here. Clean this up. Okay, and then let's test this 5.5% sodium standard and see if this salt meter is calibrated. Now in theory, I can also just flip that closed. Looks like it's settling at slightly low, 0.47, so I'm just going to adjust this standard wheel up here. Whoop. Pretty finicky. Okay, magic touch, there we go. Okay, so this is now calibrated at using the 0 and the 0.5 standard solution. So now I'm just going to go back through. I'm going to clean this off again, absorb what's there, put in a few more drops of this 0 water. Okay, clean that off, set that to the side, and now we are ready to get down to business. So let's start out with our lowest concentration. Let's just look at the salt concentration in plain tap water. Let's see what that looks like. And this again, it's measuring sodium. Okay, so not 0, but close to 0 for plain tap water. So let's look next at our 0.5% concentration. I'm not writing any of these numbers down, by the way, so it's your job to write them down. Just clean this off again. Okay, and we'll come back in with the 0.5%. Okay, very low concentration relative to what I would have expected potentially. But you have to remember, this is 0.5 sodium chloride. It's not 0.5 sodium. So your percent sodium will differ from your overall salt concentration in solution. So at 0.5, I'm getting a reading of 0.03. Okay, so let's keep trucking along. Okay, that's a more dilute solution, so if I just clean up the excess liquid that's present here on the sensor, that will not affect my next reading. Okay. Okay, so next I'm going to go for the 1%. Some instruments take longer than others to settle, so this looks like it has settled at 0.06, okay. So I can set that one aside. Wash and repeat, as they say. Okay. So 1.5. Any bets? What's that going to be? Okay, that seems to have decided, settled at 0.1. So not as linear as we might like, but given all of the messy parameters involved here, that's not a huge surprise. Let's clean that off again. Okay. So next is our 2%. Okay, that looks like 0.14. The end is near, the end is near. Clean that off. And we'll go last for 2.5. Let's see what we've got here. .17. Okay, you know, just for fun, let's see how much salt is in my saliva. This paper is non-toxic. I am in a kitchen. You shouldn't try this at home. Okay, I gave that a good lick. There you have it. My saliva is not all that salty. Okay, so that's use of the salt meter. You'll see use of some other instruments in a couple of other videos that will be accompanying this lab. I hope you had fun. I sure did. And I'll see you in the next video series.